How fast can you solve a polynomial to find its zeros? Not fast enough, maybe? Well, I got some good news for you. I'm going to show you in this video an example of how you can solve for the zeros of a polynomial in a very quick and easy way. Since speed is the name of the game, I'm not going to waste your time here in the intro. Let's go ahead and jump right into the example and I'll show you what I'm talking about. Find all the real zeros of the polynomial function f of x equals 1/3 x squared plus 1/3 x minus 2/3. So again, as always, when you're trying to find the zeros of a polynomial function, all that really means is take your function, set it equal to 0. Now, the kind of hard part from there usually is kind of figuring out what x values actually solve this equation. So we can use the quadratic equation if we wanted to, just like we did in the last example, where basically we would have a equals 1/3, b equals 1/3, c equals -2/3, and just plug it into the quadratic equation. But what I'm going to do here instead is show you an example of factoring this. Since the first example of factoring we did was a very specific type where we could use difference of squares, this one is not going to be like that because we have 3 terms. We don't just have the difference of 2 square terms like we did before. We're going to have to actually factor this. Now, the reason I want to show you how to factor this is because, you know, sometimes a quadratic like this can look a little daunting when you have fractional coefficients like this. But there's one key thing that I really want to point out here. Whenever you're factoring a quadratic in general, the first step you always want to look for is, do all of your terms have a greatest common factor? If they do, you want to start by factoring that out because that's going to make your factoring a lot easier from there. So notice 1/3 x squared, 1/3 x minus 2/3. There is a greatest common factor that all 3 of these things are divisible by, and that is 1/3. So we can actually factor out 1/3 from every single one of these 3 terms, and then hopefully we'll have something that's a little bit easier to factor left over at that point. So we can go ahead and do that. We'll pull out the 1/3. If we divide this first term by 1/3, 1/3 x squared divided by 1/3 is just going to leave us with x squared. 1/3 x divided by 1/3 is just going to leave us with an x. And then -2/3 divided by 1/3, if we pull that 1/3 out, that's just going to leave us with the -2. So basically, this now is something that probably looks a little bit more realistic to be able to factor this without, you know, having some weird factors in there. Really, whenever you have your coefficient of your x squared term just being 1, or in other words, you don't have a coefficient, the 1 is just kind of implied, you really just have to think about a list of numbers that will multiply to whatever this number is here and add to whatever your coefficient of your x term is. If there's no coefficient, it's implied that it is 1. So we need 2 numbers that multiply to -2 and add to +1. So what might those different factors be? Really, you can just take this number that you know they have to multiply to and think about what are the factors of that number. In this case, the factors of -2, we could either have -1 times 2 or -2 times +1. Those would multiply to give us -2. Well, if we need them to add to +1, we can see these first 2 here, +2 and -1 will add to +1. -2 and +1 will add to -1. So since this one adds to +1, like what we wanted, we're going to want to use these 2 factors here. So -1 and +2 are the numbers that we want. -1 and +2. So basically what that tells us, we will have x minus 1 as one of our factors and x plus 2 as our other factor. And then we still need to keep this 1/3 out front if we're going to make sure to factor that correctly. And that's all equal to 0. So basically we could factor out this x squared plus x minus 2 into x minus 1 times x plus 2. If you ever want to double check, make sure that you did that right, you could always FOIL this out and see if you end up back where you started. In this case, we should end up with a 2x, a positive 2x, and then a minus x, which would simplify down into plus 1x. And then -1 times +2 gives us -2. So that should FOIL back if we were to kind of double check our work by going backwards again. But I'll kind of move on from there. So like I said before, if you ever have multiple things being multiplied together like this, and you know that the product of all three of these terms, 1/3 x minus 1, x plus 2, the product of these three things has to be 0, that means that'll happen whenever one of those three things is 0. It doesn't matter what the other two things are, as long as one of them is 0. So that kind of gives us three separate equations that we can set up and see if there are any x values that are a solution to each of those three parts. So we would have 1/3 equals 0, which I know doesn't make any sense. Don't worry, I'll come back to that in just a sec. X minus 1 equals 0, and x plus 2 equals 0. So again, any x value that is a solution to any of these three equations will be a factor, or I'm sorry, a 0 of our original function. So 1/3 equals 0, that never happens, right? 1/3 does not equal 0. There's no x's in here, so it's not like it's dependent on whatever your x value is. There just simply is no solution to this equation. So that won't contribute anything useful for us. 1/3 does not equal 0 ever. Then we can solve this equation by just simply adding 1 to both sides. So that'll cancel the minus 1 over here, giving us x equals 1. Then we can solve this equation by subtracting 2 from both sides. So that'll cancel with the plus 2, giving us x equals -2. So x equals -2 and x equals 1 are the zeros of our original polynomial function because they solve this equation in its factored out form. And, you know, interesting thing, if we were to take 1 and -2 and plug them back into our full function, we should get 0. That's one way you can kind of confirm that your solution actually makes sense. And time. Feeling faster now? Hopefully that's the goal. Well, let's keep this brain train rolling. You're going to want to see some more examples. You're going to want to really keep nailing down this topic so that you can really pick up the pace and do them right. That's also obviously very important. So go click that video right there. I'll show you another example, a little bit different type of problem and a little bit different type of method that you can apply to really be able to do these problems fast and right so you can ace it on your next test. Let's get it.